Thank you for being here, and thank you for listening to my presentation. So my name is Alain Baur, and I'm the lead developer on HumanIK at Autodesk. And today, I will try to describe how HumanIK can help you to improve the visual look and feel of your MMO games. I will begin very slowly with very easy to understand concept, but be careful because I will ramp up very fast. So HumanIK is a C++ API to create, reuse, and modify animations in runtime. It is also used internally as inside Motion Builder and Maya as a high-level controller for authoring game character animations. In order to get a good understanding of what HumanIK does, maybe we should take a look on this standard game loop. When the player is playing its game, he's pressing buttons on the controller. There are some signals that are sent to an input manager and that are translated into commands that are interpreted by a blend tree. The blend tree is a place where the logic of the character is described. So here is where we decide whether a character should start walking, using a weapon, should start jumping, or anything else. When the decision has been taken, there is a command being sent to an animation engine that is simply applying an animation clip to the actual game skeleton. When this is done, this is sent to the renderer that transforms all this into a picture that is sent on the screen. And this happens 30 times per second to get a good sense of motion. But we all know that things are a bit more complex. And in modern games, the animation engines are made of 3 parts that have strong interaction between each other. First of this component is taking care of the FK animation. FK stands for forward kinematics. This is basically motion capture data or animation that has been handmade by an artist. It is not very flexible. It cannot easily adapt to the playback environment. And it costs a bit in terms of memory. This is why usually you need IK. IK is responsible for adapting the FK animation to the current game context. So for instance, if the FK animation that has been pre-recorded is an animation that has been recorded in a studio on a flat ground, a walk on a flat ground animation, and if during the game the character is walking on a slope, this IK module is responsible for adapting the animation on the fly to the slope so that the feet do not penetrate the ground. The last module is a physics module. It is responsible for bullet impacts, for example, or collision between body parts. Actually, this is the module that is responsible for applying the laws of motion on every body part of your character. What HumanIK is doing, it is covering this part of the animation engine. Everything you could accept from an IK package, we implement it. We also cover the not so trivial topic of the blending between the FK data and the IK data. But you have to know it right now, we are not doing physics. HumanIK is frame-based. We know nothing about masses, velocity. we only know about current positions and current orientations for all the joints of your character skeleton. Just for you to get the big picture, in this diagram, I'm displaying all the Gameware components. So you can see navigation that is able to take control of a character from the blend tree. You can see beasts that is able to improve the rendering of your game, and obviously Scaleform that adds a nice UI on top of all of this. We are all a big family, and once you get used to one of the products, it's very easy to use all the other products. So one of the key benefits of HumanIK is the full body IK solver. But in order to understand what the full body IK solver is, you first have to understand what IK is. What you see here on the screen, this is not IK. This is FK data coming from a motion capture source. It has been recorded on a real actor. It is quite heavy in memory, and it cannot adapt to the playback environment. On the contrary, IK is very flexible. The principle of IK is you define a collection of target positions and target orientations to be reached by some of your body parts. These target positions and target orientations, we call them effectors in HumanIK. You have effectors for the hips, for the hands, the wrists, for the head, for the feet, even for the fingers. And the whole promise of HumanIK is it will manage to compute very quickly a skeleton setup that is able to reach all active targets during the frame. So for instance, if I'm grabbing the left-hand effector on this character and I'm moving it around in the world, HumanIK will automatically compute all the giant transformations from the wrist to the shoulder. Obviously, this works on any body part, and HumanIK is able to reach both target positions and target orientations. But this is quite easy to code. But real game setups are sometimes much more complex. For instance, if I want this character to grab this cube on the ground, we can immediately feel that extending the arm won't be good enough. And this is where full body IK comes in. Full body IK is the ability for one effector to drive the entire body of the character. Just by moving the red effector here, HumanIK automatically bend the character's knees, curl its spine, and extend his arms. As you can see here, there is no FK. This guy is static. In a real game, you are not choosing between FK animation and IK animation. You are playing both. And HumanIK is able to blend this data. For instance, on this shot, both characters are playing the same FK animation, but the guy on the right is using HumanIK to lock its left hand position and left foot position to a static position. But as you can notice, we can still recognize the look and feel of the original animation. We are not destroying the original intent of the artists who designed the animation. And it is important to indicate that it is up to you to decide which body part can be affected or not by HumanIK. For example, if you don't want us to move the hips, we will leave it to the FK. The integration of HumanIK inside a game engine is pretty straightforward. It follows this workflow. Basically, each frame, you have to provide us with the result of your FK animation engine. You also provide the solver with a collection of effectors, target positions, target orientations. You call a single function that we'll call the solver, and we will compute the output pose. And it is up to you to apply this output pose to your game skeleton. So what can you do with this technology? How can this improve your game? I'm not going to answer this question. Sadly,
parts into parts you want.
Mathieu Latulippe couldn't do it today. Mathieu Latulippe is the technical animation director at Ubisoft. He worked on Prince of Persia, and he recorded this small customer story for us to explain how HumanIK has been used in his game in order to implement a sophisticated floor contact and also characters animations when hanging on a ledge. Please listen carefully to this testimony.
Very, very useful. Yeah, HumanIK. We ended up using it in our game as well. Actually, we had it planned all along since we already had the technology from Assassins in this case. And we had a lot of experience using it already. So we told ourselves, well, we know it works. We know it's going to work well. We know exactly what it does. So let's plug it in later. We basically left it lying there for a while, and then when we said, well, we have 2 months left, we decided to just plug it in there, and it worked beautifully. Here we have the prince without HumanIK on. As you can look at his feet, there's definitely some problems when it comes to very complicated mesh terrain. You see him floating around because you're not doing any tests on the character, so you don't have his feet lying. And then there we go. Here we have HumanIK that's on the character right now. It affects his spine, all of his lower back, his feet. It really makes a lot less work. Honestly, you don't need to make as much animation while doing this stuff. It saved us so much time, and we were really happy to have it. The only thing that I'm disappointed with when it came to installing it in was that we did it too late. There was a lot of stuff that I figured, well, you know, we could have used it elsewhere, but it was so late in production that we decided, well, we're just going to do what we planned for. Including this here. This one is actually for the hands. Here we have the original with the version that was actually built a little later than the final game, so that we could turn on and off HumanIK. Very useful for doing these kinds of demos. And here we'd have it with it on. It actually adjusts only the hands in this case. Not as complex as the feet itself, but it works fairly well. I mean, for something that would have quadrupled the amount of animations we needed to do, it really saved us a lot of time. It's not magical. I know it doesn't do your animations for you, obviously, but for everything that you need in order to fill the holes that you end up with, like here, well, it does it pretty magically. It's not a lot of work to put it in, and there you go, you know. It's one of those things that I really do not regret that we ended up installing.
So Ubisoft is using HumanIK in most of its production today. And what is great is that they perfectly know the product, and they do not waste engineering time on these animation topics. They know that they have this stable product, and they can focus on the game mechanics and on the implementation of the scenario. There are other customer stories that you can look at. We have this Gameware channel. I really recommend you to take a look at this. You will get access to many tutorials explaining, for instance, how HumanIK can be used to handle weapons. Here on this shot, the only object that is animated is a weapon. There's no FK animation here. The guy is entirely driven by the weapon itself. Obviously, you can also handle two-handed weapons like this. Here, I only animated the shotgun, and the whole upper body is automatically adapted by HumanIK. You can imagine how many animation clips you can spare using that kind of technology. Also, you will learn how you can use HumanIK, for example, to drive a vehicle or to ride a dragon. So please take a look at the Gameware channel. Basically, what you should remember about the full body IK is what we're trying to do is we're trying to get rid of the traditional animation approach, which is based on a lot of input clips that are done handmade or done through motion capture data and blended together in order to get a pretty good result. The problem with this approach is that you have to author a lot of animation clips, and this costs time and this costs money. And if you decide to change the design of your character during the game development, you have to modify all the animation files. So we try to replace this traditional approach by this modern approach where you only have a need for very few input clips and some good IK settings to get a very flexible result. And maybe it's the right time to speak about the second most important feature of HumanIK, that is retargeting. Retargeting is a process of applying an animation that has been recorded for one type of character on another type of character that can have a different skeletal structure, different proportions, a different number of fingers. The only real animation here is on this character, and it is the same animation that is retargeted on runtime on all the other characters in the scene. You can immediately understand that this is a very clever way to spare a lot of animation data and animation resources. And also in the context of MMO games, it is an easy way to spare some network bandwidth, because instead of having to transfer a lot of animation bank, you just have to transfer one. Before going further on the MMO topic, I think we should take a quick look under the hood and see, take a glance at the SDK structure itself. So HumanIK SDK is made of 3 parts, 3 layers. The top layer is a user API. This is the only layer that you will be using directly. We try to keep it as simple as possible. It is not a C++ API, it is a C API. And most of the behavior that I've shown during the presentation, you can implement them just by 10 function calls from this API. This API is obviously platform independent. You will call exactly the same function with the same parameters on a PC, on a PS3, on a mobile platform. All the algorithmic part of HumanIK is here on this layer. The main component is a solver. This is a beautiful piece of code, actually. It is the one that is responsible for, folding the character to reach all the constraints. Actually, it's an aggregation of many sub-solvers. There is one solver, for example, for the shoulders. We support up to 3 joints per shoulder to have a perfect biodynamics. You have a solver for the arm, a solver for the finger, a solver for the neck, for the spine. Also, there is this second solver here that is called the LOD solver. The intention here is to be able to do IK much faster than the standard solver. The LOD solver is running 10 times faster than the standard solver, but with less quality. It cannot work on fingers. He's approximating some body part solving, but it's perfect when you have a crowd with characters that are further away from the camera. It doesn't require a lot of precision. Then there is the retargeting solver and a collection of utility functions that you can get access to in order to debug your IK or to implement your own way of blending FK and IK data. And this last layer, we call it KCG. This is the platform-specific layer. It's mostly written in assembly language, and it's different for all platforms. We have an implementation of KCG for the Xbox, for the PS3, for the Neon, and using the special, the accelerated instruction set of the Intel and AMD processor. This guarantees that you get the most out of every individual platform. So what you have to remember about this big picture is that you only access this API. We keep it simple. It does not evolve a lot over time. We are not adding a lot of features to HumanIK each and every year. We are trying to keep the product as compact as possible. We are doing few things, but we are doing things well. I think now you have a good idea of what you can do with HumanIK on a character, grabbing an object, handling a weapon, climbing on a wall, looking. But when it comes to MMO games, there is a second issue, it's performances. Because very often you want to run IK on many characters at the same time, sometimes 10, 20, 50, maybe 100. So let's have some few words about performances. Please remember first that there are 2 solvers, and both of them are scalable. The default solver is a high-quality solver. It is the one that is used inside Assassin's Creed, for instance, to simulate Ezio that is climbing on the buildings. The second one, the LOD solver, runs usually 10 times faster, and it should be used for secondary characters in the game. The first performance factor for HumanIK is the bone count of the skeleton to solve. The lowest the bone count is, the fastest HumanIK will solve your skeletons. These are some metrics that I ran this morning on this standard laptop. This is the worst case scenario with all the effectors asking for a very complex layout. So you can see the performance is quite reasonable. And as soon as you activate the LOD solver, you run 10 times faster. And since the bone count matters a lot, we recommend in a multiple character game setup, like an MMO game, to create many versions of your character skeletons that get switched depending on the distance from the camera. For example, the one on the left should have as many bones as possible to obtain a high quality rendering when the character is near the camera. This includes finger bones, all the shoulder bones, a lot of spine bones and neck bones to be very flexible. And then when the character is moving away from the camera, you can remove some of the bones. For example, you do not need the fingers IK, so you can just remove these bones because they won't be visible at all. And this will accelerate a lot the processing. And finally, when the character gets even further, you should switch to the minimal skeleton that is supported by HumanIK. That is a 15-bone skeleton. Then there are many properties in HumanIK that you can tune progressively to improve the CPU consumption at the cost of quality. So, for instance, the pull iteration count, which is the most significant property when doing full body IK, should be progressively reduced when getting further from the camera. And then you can, for instance, stop doing IK on character fingers when it's getting further, then disabling the roll extraction. The roll improves the character solving on the arm to avoid skinning glitches, but you won't notice these glitches from further away, so you can disable it, etc., etc. Then disable the realistic shoulder mode, disable the floor contact, because at a certain distance you won't notice that the character feet are penetrating the ground. So basically it's up to you to define your LOD strategy, and we give you access to all these parameters to tune this by yourself. Another point that you should keep in mind is that HumanIK is fully thread safe. And there are plenty of other things that you can do during the IK computations. For example, you can work on the other parts, other aspects of the animation, on the AI, on the lighting of the scene. And also there is nothing that is preventing you from solving many characters at the same time. So please keep in mind that HumanIK is fully thread safe. Another performance issue we often encounter is related to data cache miss. This is mostly due to the fact that the data structures passed to the solver functions were allocated in non-contiguous locations in memory. So we provide a set of functions to create characters, character states, effector states, and properties in a pre-allocated contiguous buffer to optimize the performances. But this might sound a bit obscure to you. So I will stop talking about performances right now. We have a lot of hints to improve the performances. I'm going to show you a real-time demo featuring this. This is one of the interactive demos that we will add to the newest version of HumanIK that will get released in 1 month from now. So this is a Havoc vision engine. There is this character, Sven, with a simple FK animation running on it. And for instance, I can take control of his left hand and put it on his chest. Or I can take control of the right hand and move it like this. All the moves that I'm going to display in this shot are created procedurally and did not require any artist work. I can beat the feet.
Oppan Gangnam Style.
20 characters, 30 characters, 50 characters, 70 characters, 100 characters. All the animation is procedural. This is all full body IK running here. The skeleton of Sven is high definition, and the other characters are low definition, only 22 bones.
Gangnam Style.
I forgot to say we also support quadruped creatures. Okay, I think you get the point. It doesn't look perfect anyway. I just worked on this demo during 3 days before coming here. So remember, this is all interactive, and this is how it looks when you deactivate the IK. There is no animation at all, just a simple wait cycle. So I'm going to finish the presentation talking about the latest features we've been working on during last year. The main topic has been HumanIK everywhere. We tried to follow the remarkable trends of last year. There were 4 remarkable trends. First, it was the mobile gaming growth, with the tablets selling more than the traditional PCs. So what we did is we added full support for both iOS and Android platform. So we reworked on the KCG backend, that is the acceleration backend I've talked just before, and added and optimized this component here to support the Neon instruction set to be able to run the demo I just showed on a tablet. Here is a simple sample that we wrote 3 months ago. It's a bit old, but it shows you on a very basic tablet how to animate a skeleton with HumanIK. I can send you the APK file if you want. It's a free demo. The second trend has been the Asian market growth, with a lot of demand from MMO game developers. This is why we have been working on the performances of the LOD solver to be able to display many characters at the same time. Also, many of you asked for improvements in our Unreal 3 integration. We have an integration for Unreal 3 engine. It is made of 2 parts. There is a small game that we are delivering that implements many IK features like this one. This guy is crawling on the ground, following all the terrain shape. This feature here, there is a single climb animation that is getting adapted to any create height. The game is delivered with full source code so that you can see the details of the implementation. Also, there is this imitation of the climbing movements that you can see in Assassin's Creed. And the second part of the integration is a collection of Unreal Editor plugins that we added to the standard editor. So you can set up your characters easily from the Unreal Editor. We provide you with a collection of animation nodes that you can insert in the animation tree to take control of a chain of FK animation. And then the other remarkable trend is the development community asking for easier products and workflows. So we continue this initiative at Autodesk that is called portable characters. This means that, for example, if you're designing your character inside 3ds Max and want to animate it inside Maya, and then to change some details of the animation inside Motion Builder, you can transfer the character without losing any piece of data. And the standard representation of a character in all Autodesk applications is the HumanIK character. We also improved a lot the integration of HumanIK inside Maya and inside Motion Builder. So most of the IK and FK blend tests, you can perform them inside Motion Builder or inside Maya instead of writing C++ code. Also, we worked on a few solver improvements. The first improvement we've been working on is adding a realistic shoulder mode to the character arms. The idea is we want to get closer to what's happening in the real life. In the real life, you cannot rotate your wrist joint like this. You cannot rotate your elbow joint like this. When you rotate like this, the rotation is actually happening somewhere in between. And when implementing this feature, it adds a lot of realism to the whole arm behavior. We also we've been working also on the squash and stretch. Few people actually know that HumanIK is able to do squash and stretch. In case you are not familiar with squash and stretch, this is an optional algorithm that allows the inverse kinematic solver to automatically lengthen or shorten some character limbs, or the spines, or the neck, when a character is attempting to reach a position that is too far away. So this is very useful when you try to do some cartoon effects, for example, extending the legs like this and squashing. So this is used mostly for cartoon effects. Then we have been adding a collection of parameters to the spine retargeting so that you can have a better control on the shape of the character's back during the retargeting operations. And obviously, we've been fixing a lot of small glitches and edge cases on all body parts solver so that you can get realistic and organic movement. Okay, that's all for my presentation. Do you have any question? No question? So thank you for attending, and thank you for the translation.